Marhaba. Okay, in this session we want to talk about a new concept in the course which is called relations. Okay, so again, briefly, we want to talk about how we can talk about relations between elements inside the set. Okay, so let me define in the first place what is a relation, but before we do this, we want to recall what is the Cartesian product. So remember, if we have two sets, so let A and B be sets. Remember, how did we define the Cartesian product A cross B? So A cross B is the set of all pairs whose first element is from the set A and second element is from the set B. So how do we write this? This is the set of all pairs or two tuples. Remember, a two tuple is a sequence of length 2. So it's a sequence which has two elements, two terms, such that the first element belongs to the first set and the second element belongs to the second set. So the comma here represents and. Okay, so A belongs to A and B belongs to B. So this is the Cartesian product of A cross B. Now let's define what is a relation from the set A to the set B. So definition. Okay, so a relation from A to B, from the set A to the set B, from A to B, is simply a subset, any subset of this set of the Cartesian product is a subset, okay, of A cross B, of the Cartesian product. Okay. So this is the important notion in this session, a relation. So all from the set A to the set B. It's just a subset of A cross B. So let's think, what do we mean by this? So remark. So if, say, R is a relation, okay, from A to B, then we can say that R, using the symbols, I just want to rewrite what I said above, it's a subset of A cross B. Any sub A. So the empty set, since the empty set is a subset of A cross B, then the empty set is a relation. A cross B is a subset of itself, so A cross B is also a relation. So this means that elements of R, so R is a subset of A cross B. This means that every element of R is an element of A cross B. So elements of R are pairs of the form A comma B, where A is in A and B is in B. Okay. So this is the concept of a relation. It's just a subset of the Cartesian product. Now, so since it's a subset, if the pair A comma B belongs to R, so suppose we are given a relation R, so R is a subset of A cross B, suppose this pair belongs to R, then we say okay, that the element A is related, okay, is related to the element B by the relation R. So this is just a way of saying that the pair AB belongs to the set R. So remember, R is a relation, which means that R is a subset of A cross B. Okay, we also write ARB or R bracket A comma B, or sometimes we use the diagram A arrow B. Okay, so all of these ARB, RAB, or A arrow B, or A is related to B by R, all of them are different ways to say that the pair A comma B is an element of the relation R, and again, by a relation we mean a subset of A cross B. where A, B are sets, and A cross B is the Cartesian product of the sets. Okay, so let's have a particular example. So here is an example of a relation. Suppose we want to talk about a relation from A to B, where A is the set 1 containing 2 elements 1 and 2, and B is the set containing 3 elements A, B, and C. And suppose we are given the relation, so consider the relation R, where R is the following set. It's the set containing this pair and this pair and this pair. So R is a relation, it contains 3 elements, and notice that R is a subset of A cross B, because every element in R is an element of A cross B. What is A cross B? It is the set of all pairs such that the first element is 1 or 2 and the second element is A or B or C. See, these 3 elements satisfy this condition, and this means that R is a subset of A cross B. So this means we can say that under this relation we can say that the element 2 is related to the element B by the relation R, right? Why is this? Because notice that the pair 2B is an element of R. Okay, see, this is an element in R. It's a one element, and either you say the pair 2B belongs to R, or you say 2 is related to B by R, or you write 2RB, or you write R to B, okay, or you use the arrow diagram. But we can use the arrow diagram here to represent all the relation R. So let me do it here using the blue, say. So here we have 2 elements representing the elements of A, 1 and 2, and here we have 3 elements representing the elements of B, A, B, and C. Okay, and from this pair, we know that 1 is related to A, so we can use the arrow notation to represent this. Okay, and now what is the second one? The second one is 1 is related to B, so we can use an arrow here to show that 1 is related to B, and the third for this one, and the third pair is 2 is related to B. Okay, so this arrow diagram, 1 related to A, 1 related to B, 2 related to B, represents the relation R. So this is how we use arrows to represent relations. Okay, now, okay, one might say, okay, relations look like functions, but you see from this example that this relation is not a function, can't be seen as a function, because this element has 2 images, right? And we know in a function every element in the domain, here it's A and codomain B, should have 1 and only 1, exactly 1 image. Here we have 2. Okay, but we will see later that every function can be seen as a relation, but not the other way. So not every relation can be seen as a function. This is an example where we can't consider this R as a function. Okay. So relations are a more general concept than functions. Okay. Now let's take more examples. Let's consider this relation. So maybe I have first to say one comment. If A is equal to B, so R is a relation from A to itself, okay, from A to A, then we just say that R is a relation on A. A relation on A. So when you see when you see the term that R is a relation on A, it means it's a relation from A to itself, to A. Okay, what does this mean? It means that R is a subset of A cross A. So A is a subset of the Cartesian product of A with itself. When this is the case, we just say R is a relation on the set A. Okay, let's take an example of a relation on a set. Let A be the set of the first four positive integers, 1, 2, 3, and 4, and consider the relation which represents the less than, strict less than relation. So what is this? 1 is related to 2 because 1 is less than 2, 1 is related to 3, 1 is related to 4, 2 is related to 3, okay, comma 2 is related to 4, and 3 is related to 4. Okay, so this is a relation. Clearly check that this is a subset of A cross A, right? Every element here, so 1, 3 is an element of A cross A because 1 belongs to A and 3 belongs to A. Now, what else? So we can say that, for example, 3 is related to 4. You can also say that R, so now the symbol we are using R subscript less than 3, 4, or you can use an arrow to represent 3 is related to 4. Now, but look that 3, 1 does not belong to this relation. Okay, so we can write that, we can say this, that 3 are 1 and make a cross. So R is not related to 1, which means that the pair 3, 1 is not an element in R. Okay, so this is R. You are given R, and you can see that none of the pairs inside R less than is the pair 3, 1. Okay, so we can write it this way, that R is not related to 1, sorry, 3 is not related to 1 by R. Okay. Now, if you want to use the arrow diagram for the whole relation, so now remember we have the 1, 2, 3, and 4. Okay, maybe I can use another copy of A and say, or I just, because it's A cross A, okay, or I just use one copy, and we know that 1 is related to 2, so I put an arrow, 2 is related to 3, 3 is related to 4, 1 is related to 3 as well because 1 is less than 3, right? And 1 is related to 4. And what else do we have? We have that 2 is related to 4, and that's it. Okay, so here 1, 2, 3, 4, 5, 6 arrows representing the 6 pairs, 1, 2, 3, 4, 5, and 6. So either you write it in terms of pairs, or you can represent a relation which is a subset of A cross A in this example using the arrow diagram. By the way, the arrow diagram, we call it a directed graph, and for short, digraph. Okay, when you have vertices like points and arrows, such object in mathematics is called a directed graph or digraph. Okay. Now let's take another relation. What about the relation R, which contains all the pairs m, n, where this element is a subset of the positive integers cross the positive integers, such that m divides n. Okay, so look what I'm doing here. R is a relation on z plus, on the positive integers. So why it's a relation on z plus? Because R clearly is a subset of Z plus cross Z plus. Look, by definition, R is the set of all pairs of positive integers such that the first term in the pair divides the second. Okay, let's have examples of elements of R. Okay, so for example, 4, 8 belongs to R, right? Because 4 divides 8. We can write this as 4 arrow 8, or you can write this as R, 4, 8. Okay, another example is what? 7 and 21, because 7 divides 21. Belongs to R. Okay, now 5 and 18 is not an element in R because 5 does not divide 18. Okay, so we can write 5 is not related by R to 18. And what is R? This is R. It is the set of all pairs where the first divides the second in the pair. So if you want to use the arrows to represent this relation, okay, we can start by listing the positive integers, okay, and so on. You can work on this copy, or you can take, for clarity, we can have another copy of the positive integers. Why I'm talking about two copies? Look, this is Z plus cross Z plus. Okay, 4, 5, 6, and so on. And we know that 1 is related to 1 because 1 divides 1, and it's related to 2 as well, and it's related to 3. Actually, 1 is related to every positive integer because 1 divides any integer. Now 2 divides itself, and it divides 4, and it divides 6, and so on. 3 divides itself. It doesn't divide 2, it doesn't divide 1, it divides 6. Okay. 4 divides itself, and it divides 8, and it divides 12, right? And so on. So we have infinitely many arrows, okay, because this is, look, this set is infinite. R is infinite here. But, okay, countably infinite by the snake argument. We can list all the elements of R here. Okay. Now let's see how can we see that every function is a relation. So let f be a function from domain A to codomain B. Okay, so be a function. Then how can we see then f can be seen as a relation? So is a relation from A to B. How can you see this? Again, what is a relation from A to B? It's a subset of the Cartesian product. What is this subset? Okay, before I say it, tell me, what do we call this subset which represents f? It's called the graph of f. So the graph of f, what is the graph of f? It is the set of all pairs AB such that A belongs to A, B belongs to B, and the second term is the image of the first term under f. So f of A is equal to B. Okay, so since the graph of f is a subset of A cross B, then by definition it's a relation. Because this is what is a relation from A to B. It's a subset of A cross B. Okay, so this means that every function can be seen as a relation, but not vice versa. Not every function and not every relation is a function. We've seen this before. Because one element could have two images or more. Okay, so relations is a more general concept than functions. Okay, let me finish this session by the following observation. let A be a finite set of cardinality n. Okay, suppose A has 10 elements. Okay, this is a question from combinatorics. How many relations are on A? So now you should stop the video and answer the question yourself. How many relations are on A? Okay, so to figure out this question, you need to answer yourself, tell yourself what is a relation on A. A relation on A is a set R. It's a subset of A cross A. So for every subset of A cross A, we have a relation. So the question boils down to asking how many subsets of A cross A are there. Okay, so how many subsets of A cross A? We know that this is, okay, so the answer is the cardinality of the power set of A cross A. Right? Because what is the power set of A cross A? It is the set of all subsets of A cross A, and this is what we want. So the cardinality of the power set of any set is 2 to the power the cardinality of the set. And we know from the product rule that the cardinality of A cross A is the cardinality of A times the cardinality of A. But what is the cardinality of A? It's n times n. So 2 to the n squared. There are 2 to the power n squared, okay, of different relations from A cross A. Okay, so for example, if A has only one element, say star, okay, then how many relations are on star? So if n is 1, 1 squared is 1, 2 to the power 1 is 2. So there are 2 relations. Okay, what are the relations? One is, so let's call it R1, which is the empty relation. No element is related to any element. And the second relation, R2, is, notice that this is a subset of A cross A. And the second relation is star is related to itself. And this is A cross A. This is A cross A. When this is example, okay? So this is represented by star and no arrows, and this is represented by star, which is related to itself. Right? Star is related to itself. Now you do another example on B, say, look at the set B, and B contains 2 elements, X and Y. And we know from here that there are 2 squared is 4, 2 to the power 4 is 16. So here there are 16 different relations, okay, on B. What are the relations? All the subsets of B cross B. So find the power set of B cross B. Now what is B cross B? B cross B is XX, XY, YX, and YY. All these pairs. Now you need to figure out all the power set of this set. So you have the empty set, this is the first relation, or the set containing just this pair, and this can be represented by X related to itself, or XY, and this means that X is related to Y, or the pair YX, and this means that Y is related to X. Here's another relation, so we have XX, say, XY, and YX. Okay, what is this relation? It means, so here is X and here is Y. XX means X related to itself. This is this pair. XY means X is related to Y. and yx means y is related to x. So you should continue to list the 16 relations. Okay, so this is 1, 2, 3, 4, and 5. There are 11 more relations. Okay, so for example, b cross b itself is a relation. So what is it? So if this is x and this is y, so xx means x is related to itself, xy, x is related to y, yx, y related to x, and finally yy means y is related to itself. So this diagram is the relation, is the full relation, b cross b.